In science and research, a variable is a characteristic or attribute of things. But in probability, which is what we are dealing with now, a random variable is an expression whose value is the outcome of an experiment. And in this case, experiment is not a scientific experiment, but it is a random process, like tossing a coin or rolling a dice, or as we are going to become familiar with, a drone landing in a city. So let's consider the example of a city represented here by the large rectangle called Z, and the city has 4 regions: region A, region B, region C, and region D. Now the total population of the city is 1 million. Region A has 400,000 people, region B 300,000, region C 200,000, and region D 100,000. So the experiment here is observing the first landing of the drone in city Z. And the specifics are that this is a city and there is a drone delivery pizzeria which delivers pizza by drone, and the preference for pizza is equally distributed across people, so there is no more preference in any region. So what we want to know is today what will be the first, in which of the regions will be the first landing. So now we are going to become a bit technical about random variables and probability. So one important thing is what is called the sample space of the experiment. And the sample space is represented by the Greek letter omega, big omega. And the sample space is the set of all the possibilities of the experiment. So we've got this small omega 1, small omega 2, small omega 3, and small omega 4 are the components of the big omega set or sample space. So the sample space is the sum of all those possibilities, and all the possibilities are clearly expressed here, and they are in text. If drone lands in A, that's what we call an elementary event called omega 1, and if drone lands in B, is another elementary event called omega 2. If the drone lands in C, it's omega 3, and if the drone lands in D, is omega 4. Okay, so now we are going to transform this into a random variable. So for convenience, random variables use numbers. And so the values that can take a random variable are numbers. So we are going to say that the random variable x will take the value 0 if omega 1 is true. So basically omega 1 is that the drone will land in A. X is going to be 1 if omega 2 is true. So if the drone lands in B. X is going to be 2 if the drone lands in C. And X is going to be 3 if the drone lands in omega 4 or in D. So now we have events. So before I call you these omega 1, omega 2, omega 3, and omega 4 elementary events, but we can have other events that are not elementary, that are all the possible subsets of the big omega set. So by simple set theory, we can know that there are a number of possible subsets of omega. So we call event A when the subset is 0, event B when the subset is 1, event C when the subset is 2, event D when subset is 3. Or we call it event West when subset is 1, 0, 1. So basically that means that the drone lands in A or B, or in omega 1 or omega 2. And event East is when lands in 2 or 3, or omega 3, omega 4. Event O we call the empty set. So basically that the drone doesn't land in any area of this sample space. So we are going to give that a probability of 0. Sometimes we don't even consider the empty set, but we can consider it and give it a probability of 0. So it cannot not happen. We assume that there will be a landing in city Z, so it cannot be outside city Z. And the event Z is the whole set, so 0, 1, 2, 3. So basically that the drone lands either in 0, 1, 2, or 3, which is omega 1, omega 2, omega 3, or omega 4. So basically the probability of event Z is 1, because it will happen definitely that it will land in at least one of these regions. Okay, so let's start. We talked about the sample space, which are the possibilities in the experiment, but now we haven't talked about probabilities. So in order to talk about probabilities, we first use a function we will call m, which we will apply to each of the omegas, of the little omegas. So m of omega 1 is 0.4. Why 0.4? Well, because in omega 1 is region A, which has 400,000 inhabitants and over 1 million inhabitants. That means that 40% of people live in that region. So we give a probability of 0.4 for the first landing being in that area, because there is a 40% chance that the first person who will call to get a pizza comes from that area. M of omega 2 is a function that will assign the value 0.3 to omega 2. That means that is because the population in omega 2 or in region B is 300,000 over a million, which is 30%. So in terms of probability would be 0.3. And the same with m of omega 3, it's 0.2 because 200,000 people live in that area, and m of omega 4 is 0.1 because 100,000 out of 1 million people live in that area. Okay, so some characteristics of these. Now, don't panic with these a lot of Greek letters and scary signs. I'm not going to require you to know this, but I wanted to show just one characteristics of probabilities. So this m function that assigns a value to the omegas, it has to be equal or higher than 0. So that means that there are not negative probabilities. Probabilities have to be 0 or more. And that's for all omegas that belong, so omegas, little omegas, that belong to big omega. So remember, big omega is the whole set of possible outcomes of the experiment. And little omega is each particular outcome in that belongs to big omega. Now, so that big sigma means sum. So again, this is a bit scary, but it's only saying sum everything that comes after it. Okay, so sum all the m of omegas. And here underneath says for all omegas that belong to big omega, which is the same that says here. So for all omegas that belong to big omega, which are omega 1, omega 2, omega 3, and omega 4, then we sum all of them. So that sum must be 1. So when we add the probability, or which is in the function m, of omega 1 plus the probability for omega 2 plus the probability for omega 3 plus the probability for omega 4, that must be 1. For any subset E, and E we use to refer to events of big omega, the probability of E, or the event, is probability of E equals, the sigma means sign, for all omegas that belong to that E, and then we sum all the function m's of those omegas. So let's say we consider event E equals 0. Then we have to sum all the omegas that belong to that event that is this subset 0. So there is only one omega, which is omega 1. And the m of omega 1 is 0.4. So the probability of that event is 0.4, which is the same as the probability of omega 1. Why? Because omega 1 is an elementary event. So this E, in this case, is the elementary event which corresponds to omega 1. If E is just this 1, that is the probability for omega 2, which is 0.3. If E equals 2, then we have to look at the probability of omega 3, which is 0.2, and if E equals 3, then we look at probability of omega 4, which is 0.1. But we've got remember the event that we can call west, which contains the elements 0 and 1. So 0 and 1 corresponds to omega 1 and omega 2. So we have to consider now omega 1 and omega 2, and in order to determine the probability of that event, so that's the probability that the drone will land either in omega 1 or in omega 2. So what do we have to do? We have to add all the m's for the omegas that belong to that event. And the omegas that belong to that event are omega 1 and omega 2. So remember, omega 1, the probability for omega 1 was 0.4, and the probability for omega 2 was 0.3, so the addition of these two is 0.7. So that's why we have PE equals 0.7 if E corresponds to the subset that contains the value 0 and 1. Now, if D is the event that we can call east, corresponds to the subset with elements 2 and 3, then that corresponds to omega 3 and omega 4. So following this formula, it means we have to add the probabilities for all the omegas that belong to this event. And this event has only two omegas, omega 3 and omega 4. So omega 3 was 0.2, omega 4 was, the probability for omega 3 was 0.2, the probability for omega 4 was 0.1, so I just add the two, 0.1 plus 0.2 plus 0.1, and that's 0.3, like here. If the event is the empty set, well, probability of that event would be 0, because the landing of the drone will occur and will occur within the city. We make that assumption. And if the event is the full set or big omega, then the probability of that event is 1. So basically we have to add the probability of omega 1 plus the probability of omega 2 plus the probability of omega 3 plus the probability of omega 4, and that must be 1 by definition. So we got that answer.